Simplifying radicals involving imaginary numbers. Now the first thing to know is the square root of a negative 1 specifically, is equal to I. And that I squared is equal to -1. So these are the first two rules we need to remember when dealing with radicals that have imaginaries in them, and when dealing with imaginary numbers. So first off, if I have the square root of -4 plus the square root of -25 minus 2 square roots of 75, well, the only thing that changes from the part 1 we were watching, where we were just simplifying radicals, is that if there's a negative underneath, it produces an I with the number. So for example, 4 is the same thing as 2 times 2 if we factor tree it. So since there's a pair of 2's, we can bring a 2 out. But because of this negative, it becomes 2I. -25 breaks down into 5 and 5. Pair of 5's means a 5 comes out. The negative means it tacks on an imaginary number. This part right here becomes 5 times 5 times 2. Pair of 5's means 1 comes out and times is to the 2 out front to make 10. And the leftover 2 stays inside. Well, we can combine these two numbers to make 7I minus 10 square roots of 2. Okay, let's try another example. So say now that, for example, we have square root of -8 cubed. So this is the same thing as saying square root of -8 times square root of -8 times square root of -8. Well, two of them, because this is a square root, because of the 2, it just takes 2. Remember, if we're timesing radicals, we can combine them to say -8 times -8 times -8. Well, if I have 2 of them, 1 come out, the one that's left over stays inside. Well, if we break down 8 into its factor tree, I'm going to do this in a different color just so we can see it, the difference. We have 2 times 4 and 2 times 2. Well, the pair of 2's brings 1 out, so 2 times the -8 out front becomes -16. This 2 stays underneath with the negative. One more step. So we can rewrite with the negative. Instead of putting the negative underneath, we'll put an I in front to bring out that negative power, so it becomes that imaginary number. Well, square root of negatives produce i's, but what happens when we start multiplying i's together? So 2i times 3i follows similar rules to 2x plus times 3x. Because if I had this, I would just say that's 6x squared. I would add the powers. Well, the same thing happens when I times i's. So the 2 times 3 produces a 6. I times I becomes I squared, just like x times x becomes x squared. Well, remembering at the beginning we made mention that I squared is the same thing as -1, so this is really -1 times 6, or it's -6. If, for example, I had 2i times 3i squared, this would be the same thing as 2i times 3i times 3i, because there's 2 of them. 2 times 3 is 6. 3 times 6 is 18. I times I makes 3 i's, or I cubed. Now, this is the same thing, though, as saying I squared times I. So we can break it down into the two pieces. I squared produces a -1, and the leftover I stays. So 18 times -1 becomes -18, and the I stays on the end. So for example, if I have I to the 4th, I would say that's I squared times I squared, which is -1 times -1, or just 1. So I to the 4th is actually the same thing as 1.